In this video, I will explain question number 5, 6 and 7 of exercise 13.2. Question number 5. A vessel is in the form of an inverted cone. Its height is 8 cm and the radius of its top, which is open, is 5 cm. It is filled with water up to the brim. When lead shots, each of which is a sphere of radius 0.5 cm, are dropped into the vessel, 1/4 of the water flows out. Find the number of lead shot dropped in the vessel. So here we are given an open vessel. It is in the shape of a cone. And it is filled with water up to the brim. That means the volume of water is equal to the volume of the conical vessel. So here we can write an open vessel is in the form of an inverted cone with height 8 cm. The height of the conical vessel is 8 cm and the radius of the top is 5 cm. So here the radius is 5 cm. And it is filled with water and a spherical lead shot of radius 0.5 cm are dropped into the vessel until 1/4 of the water in the vessel is flows out. So these are the things given. So we have to find out the number of lead shot. Here we can write the volume of water in the vessel equal to volume of the conical vessel. Also, on dropping a certain number of lead shot into the vessel, 1/4 of the water flows out. That means volume of all lead shot dropped in the vessel equal to 1/4 volume of the vessel. Now we have to find out the volume of the vessel. That is volume of a cone equal to volume of water in the cone. That means we can use the formula of volume of cone. Volume of cone is 1/3 pi r square h. Here r equal to 5 cm and h is given. H is 8 cm. Now put the values. You will get 200/3 pi centimeter cube. This is the volume of water in the cone. Now we have to find out the total volume of water overflows. Overflows means when we are putting a lead shot in the vessel, 1/4 of this water flows out. We can calculate that water. That means the total volume of water flows out, that is equal to 1/4 of 200/3 pi. That is 50/3 pi centimeter cube. Now we find out the volume of lead shot. Lead shot, we can use the formula of sphere. It in a spherical shape. Volume of a sphere is 4/3 pi r cube. Here r is the radius of the sphere. Radius of the sphere is 0.5 centimeter. 0.5 is equal to 1/2. So r you can take as 1/2. So simplify it here. 4 into pi into 1 into 1 into 1 divided by 3 into 2 into 2 into 2. You will get 1/6 pi. So this is a volume of one lead shot. Now we have to find out the number of lead shot. The total volume of the water overflows, that is equal to the total volume of the number of lead shot, that is equal to 50/3 pi. So for finding the number of lead shot, we have to divide total volume of water that flows out divided by volume of one lead shot. That means 50/3 pi divided by 1/6 pi. Dividing pi and pi cancel, you will get the answer 100. That means there are 100 lead shot. So here we found the number of lead shot equal to 100. Now we will move to the next question. Question number 6. It is given a solid iron pole consists of a cylinder of height 220 cm and a base diameter 24 cm. which is surmounted by another cylinder of height 60 centimeter and radius 8 centimeter. Find the mass of the pole given that 1 centimeter cube of iron has approximately 8 gram mass. So here you can see two cylinders are there. A solid iron pole consists of a cylinder of height 220 centimeter and diameter 24 centimeter, which is surmounted by another cylinder of height 60 centimeter and radius 8 centimeter. So in the figure we can see here two cylinder, one big cylinder of height 220 centimeter and above it one small cylinder that of height 60 centimeter and radius 8 centimeter. The volume of iron pipe or iron pole, that is equal to volume of this larger cylinder plus volume of smaller cylinder. We have to find the volume of these two cylinder, then find the sum of the volume. Then you have to find the mass of the iron. It is given 1 centimeter cube of iron has approximately 8 gram. So mass of iron in the pole equal to 8 gram into volume of the solid iron pole in centimeter cube. So here first we have to find out the volume of iron pole. We can use the formula of cylinder. The volume of a cylinder is equal to pi r square h, and where r and h are the radius and height of the cylinder respectively. So first we will find the volume of big cylinder or large cylinder. Given that the height of the big cylinder is equal to 220 centimeter and the radius equal to 24 by 2, that is 12 centimeter. So the volume of the big cylinder equal to pi r square h. For big cylinder we are using here capital R and capital H. And simplify it, 22 by 7 into 12 square into 220. So you will get 99565.8 centimeter cube. This is the volume of big cylinder. Now we will find out volume of this small cylinder. Same formula you can use, pi r square h. Here we are using small letter r for radius and small letter h for height of the cylinder. So small letter h, that is equal to 60 centimeter and radius equal to 8 centimeter. So volume of the smaller cylinder equal to pi r square h, that is 22 by 7 into 8 square into 60. You have to simplify it. You will get 12068.5 centimeter cube. Now we have to find out the volume of the iron pole. That is the volume of iron equal to volume of the big cylinder plus volume of the small cylinder. That is 99565.8 plus 12068.5. Add it both, you will get 111634.5 centimeter cube. So this is the volume of iron. Now we find out the mass of iron in the pole. Then the mass of 1 centimeter cube of iron is 8 gram. So mass of iron in the pole equal to 8 gram into volume of the solid iron pole in centimeter cube. Now 8 into 111634.5. You will get 893076 gram. This gram you have converted into kilogram. 1 kilogram is 1000 gram. So you divide it here by 1000, you will get 893.076 kilogram. That means you can write as the mass of iron in the pole is 893 kilogram approximately. So this is the mass of the iron in the pole. So for finding mass, we have to find out the volume of the object. It can apply in any other question also. Suppose we have to find out the mass of the material, so we have to find out the volume of this object first. Then the mass of this material you can find out. Now we will move to the next question. Question number 7. It is given a solid consists of right circular cone of height 120 centimeter and the radius 60 centimeter, standing on a hemisphere of radius 60 centimeter. He is placed upright in a right circular cylinder full of water such that it touches the bottom. Find the volume of water left in the cylinder if the radius of the cylinder is 60 centimeter and its height is 180 centimeter. So in the figure you can see a cylinder is given. The total height of the cylinder is 180 centimeter and the radius equal to 60 centimeter. And inside this cylinder a solid is there. A solid consists of a circular cone and a hemisphere is placed inside this cylinder. So this solid inside the cylinder consists of cone and hemisphere. The height of the cone is given. The height of this cone is 120 centimeter and here the radius of the sphere is 60 centimeter. That means the radius of the hemisphere is same as the radius of the cylinder. And also the height of this hemisphere is same as the radius, that is also 60 centimeter. Now we can write from the figure. We observe that the solid fit totally into the cylinder as the height of the solid is same as the height of this cylinder. Here you can see the height of the solid 120 plus 60, that is 180, and height of the cylinder also 180. That means this solid is completely fit inside this cylinder. Since the cylinder was full of water before immersing the solid into it, so the entire space in the cylinder is occupied by the solid and the leftover water. That means the volume of the cylinder is equal to volume of the solid plus volume of the water left in the cylinder. So we can find out the volume of the water left in the cylinder is equal to volume of cylinder minus volume of the solid. That again you can write as the volume of the water left in the cylinder equal to volume of cylinder minus volume of hemisphere minus volume of cone, because the solid consists of cone and hemisphere. So this is a formula we have to apply here. The volume of water left in the cylinder equal to volume of cylinder minus volume of hemisphere minus volume of cone. Now we can substitute the values. Here radius of the hemispherical part or radius of the conical part and radius of the cylinder, all these are same, that is equal to 60 centimeter. And the height of the conical part or height of the cone equal to 120 centimeter, and height of the cylinder we take as capital H, that is equal to 180 centimeter. So volume of the water left in the cylinder is equal to volume of the cylinder minus volume of the hemisphere minus volume of cone. Here we can substitute this formula here first. Volume of cylinder is pi r square h and volume of hemisphere is 1 by 3. Volume of hemisphere is 2 by 3 pi r cube and volume of the cone is 1 by 3 pi r square h. Substitute this formula, then simplify it. Here you can see 1 by 3 pi r square is common factor, or we can take it as a common factor. So 1 by 3 pi r square is taken outside here, and inside the bracket you can write 3h minus h minus 2r. So it is clear the capital H means height of the cylinder and small h is the height of the cone. Now you have to substitute the values. 1 by 3 into 22 by 7 into small letter r is 60, that is 60 into 60, and in bracket 3 into 180 minus 120 minus 2r, 2 into 60, and we have to simplify it, and simplifying you will get 792,0000 by 7. Then again divide it. You will get 11,314,26.57 centimeter cube. So here you got the answer in centimeter cube. For the convenience, you can convert it into meter cube. Meter cube is 1.13142657 meter cube. This is the volume of water left in the cylinder.